This section, we're covering actually two sections in chapter 15, 15.4 and 15.5. And in these sections, we are still graphing. We talked about those earlier in sections 9.1 and 9.2, but there we were just plotting points and plotting lines. And so now we're adding on to that with a new type of equation. And the equation we're talking about now is called a quadratic. And a quadratic equation, now this is slightly different from the quadratic formula you're looking that some of you may have memorized before. But a quadratic equation is of the form ax squared plus bx plus c equals 0. Now, it doesn't have to necessarily equal 0. It might equal y or something like that. And in order for this to work, a cannot equal 0. If it is, we would have 0 times x squared. And so that x squared term would disappear. And it's really that part right there that we have our variable raised to the second power that makes it a quadratic. And quadratic equations create, when you graph them, something that looks an awful lot like a parabola, kind of like a stylized U. It may open up like that one I just showed, or it may open down like this one, something like that. They do keep going forever up or forever down, depending on what direction it's going. But let's go ahead and graph one so that you can get a sense for what that might look like. And we will graph it just like we did some of those linear equations by creating an XY table. I remember mentioning in class that we could really graph anything if we created an XY table. And so let's go ahead and do that with this particular quadratic equation. And if you'll recall, we talked about independent and dependent variables. How the independent variables, like x in this case, are where we plug in values. The dependent variable would be like the y. That's what we get out when we plug in those values. So in the problem I'm looking at, it says use the integers between -3 and 3 inclusive, which means we have to include -3 and 3. So I'm going to go ahead and create my little table here, and we will grab those integers from -2 to 3 inclusive. And so now we can plug those values in for x. So I'm going to write this with parentheses where the x is, just so that I can then plug in the -3 for this first one. Replace every x with a -3. Now here I really want to point something out, and we may have talked about this earlier. When you square -3 and you put those parentheses around it, that is the same as -3 times -3. And you've heard that a negative times a negative is a positive, so this would give 9. So when you square the negative, you also have to include the idea that it's a negative times a negative. Now, this is a little different from -3 squared. With this one, we have -3 times 3. Notice it's only the 3 that's squared if it's not in the parentheses like that. So now we have that negative out front, and 3 times 3 is 9. So -3 squared, you square the 3 and then negate it, whereas -3 quantity squared, you take -3 times -3. And I mention that because we have that in this particular problem. The first term is -3 quantity squared, which is -3 times -3, that's 9. Plus a -3 is like -3, -6, and 9 minus 3 minus 6 is 0. So this creates the ordered pair, the x we chose and the y we got out. So now if I plot that, I come over here to -3 and go up or down 0 and put a point. So now we've got that point. And so now we can plug in the -2. I'll do the same thing with the parentheses here, just to highlight that we are replacing x with a negative, oh, with the -2. I wanted to do that in red. So -2, where the x was. So now I have -2 times -2, that's 4, plus -2 is -2, and then -6. 4 minus 2 is 2, minus 6 is -4. So I have the point -2, which is the x we chose, and the -4, which is the y we got out when we plugged in the -2. So I come over to -2, and the y is -4 from that. So I drop 4 and put a dot. Now we'll do the same thing with, oh, this was supposed to be a -1. I'm just going to go ahead and write those in black. Color, I suppose, doesn't really matter as long as you get the process down. -1 times -1 is 1, plus -1 is like -1, and then we have -6. 1 minus 1 is 0, -6 is -6. And so I have the point -1, -6. And so now I can plot that, move to -1 on the x, and then drop down to -6. Gives me a point on the graph. Let's go ahead and plug in 0. Zero squared is 0, plus 0, minus 6. That 2 is -6. So at the 0, I am still at -6. Seems kind of interesting that I got the same value there, isn't it? All right, well, let's keep going. We can see that this is going to curve and make kind of that curve shape that I talked about. Now let's go ahead and plug in a positive one. Can't forget to square that first one. 1 times 1 is 1, plus 1 minus 6. 1 plus 1 is 2, minus 6 is -4. So we have the point 1, -4. And as you might expect, our graph is now headed back up. Plug in 2. I don't know what I'm going to get yet, so let's go ahead and plug that in everywhere there was an x. 2 times 2 is 4, plus 2 minus 6 equals 0. So we've got the point 2, 0. And that's right there. And then we have this last point with a 3. We've got 3 squared plus 3 minus 6. 3 times 3 is 9. Plus 3 is 12. Minus 6 is 6. So this would be the point 36. So now I've got that point. Come over to 3 up to 6. And the graph will have to connect all of those. Now, it's not going to come down and go straight across. It's got to come a little below that point. I don't know how far below the point it'll go, but, well, that's not very straight at all. We kind of want it straight, but it gives us a good sense for what we're up against. So that would be the graph of y equals x squared plus x minus 6. And we just picked some x values and got the corresponding y values that we could then create those ordered pairs and plot them. Now, there are some things that we will be asked beyond just what does the graph look like. We will be asked for the domain. And I think we talked just a little bit about that before, but these will be the x values allowable. And with these quadratics, oh, what was I writing? I'm not sure what that word was. Okay. All right. So what X values or what values could we plug in here and get a corresponding Y value? Well, once you look at the graph, you can see that this thing is going to keep opening it up and it'll keep widening as it goes. There's nowhere in there that we cannot have that the graph doesn't touch right to left as far as X values. And there's no number that we could plug in for X in those two places that would make a problem. Therefore, the domain is all real numbers. For these, where the X term is squared, the domain will be all real numbers. And then they will ask for the range. And the range are the corresponding Y values. Meaning, what are the Y values we got or that show up on our graph? In this case, notice we had a Y down here a little below -6, and everything else is above that, as far as the graph goes. Once you have it graphed, it's pretty easy to see the range. And so our range will be all real numbers greater than, and I'll just use the number symbol, that are greater than negative, I'm going to say 6.25. I don't know what the number will be. It's a little below -6. But it'll be everything above that because those arrows show that this keeps going up forever. And so now we can state the domain and the range and come up with the values. Let me show you a homework problem so you can see what this will look like. So here we've got the problem y equals 4x squared. I need to first create my table of solutions. So I'm going to hide this one and add another layer on here so that I can do this one. Y equals 4x squared was the problem. And let me bring that back up to make sure we're doing the right one. Y equals 4x squared is the problem, and they want us to choose X values from -2 to 2. So let's create our XY table, and we'll choose X values from -2 to 2. And they'll want us to type in the Y value. So again, we're going to replace the X in the equation with the X we chose. So in this case, we are going to have 4 times, what is -2 times -2? Negative times a negative is a positive, and 2 times 2 is 4. So we get 4 times 4, which is 16. So the point that we'll be graphing has an X value of -2 and a Y value of 16. Let's do the others. We've got 4 times -1 squared. Got that 4. -1 times -1 is 1, and 4 times 1 is 4. So this will be the point -1, which is the X we just chose, and 4. We'll plug in 0. 4 times 0 times 0 is 0, and 4 times 0 is 0. So our point is 0, 0. Plug in the 1. We've got the 4 out front. 1 times 1 is 1, and 4 times 1 is 4. So here we've got the point 1, 4. And then we'll plug in the 2, and you'll expect this, I think. We've got the 4 times 2 squared. 2 times 2 is 4. 4 times 4 is 16. So this will be the point 216. Now, my particular graph on the screen right now doesn't go that high, but that's okay. When we graph, they will want us to use only 3 points. I know they have us calculate 5, but the graph itself will only want 3. So I'm going to go ahead and choose the three middle ones where we had a negative 1, 4, we had a 0, 0, and we had a 1, 4. And then we had, of course, 2, 16, which was way up high, and negative 2, 16. And so this is going to scroll up and scroll up like that. That's what this graph will look like, or something like that. So let's go ahead and now fill in those points we just got. So when we had a negative 2, we had 4 times negative 2 squared gave us 16. 4 times negative 1 quantity squared was 4. 4 times 0 quantity squared was 0. 4 times 1 quantity squared is 4. And 4 times 2 squared was back to 16. So I'll go ahead and check those answers. Those are correct. And now they want me to graph it. So you just click in the graph, the coordinate system. It brings up the toolbox. Now, this time we want this 3-point quadratic tool because we're graphing a quadratic equation. We know it's a quadratic equation because it's got that x squared out in the front. So I'm going to pick the 3-point quadratic. And even the name says we're only going to want 3 points. So I'm going to come over here to negative 1, 4. And notice down here in the corner, it tells me what the ordered pair is where my cursor is. So I can go until I see exactly what I expect, that negative 1, 4, and I click once. And then we had the point 0, 0. So I'm going to come down to 0, 0 and click that. And then when I go over to 1, 4, which was another point we had, and click that, it will finalize the quadratic graph. And then I can check my answer and we're right. And now it will ask me for the domain. As I said before, the domain of these will be all real numbers when it's the x squared. So I can just select that and check my answer. The graph shows it. We can't think of an x value we could plug in that will break it. So that's true. Now, looking at the graph, we want the range. Notice this graph starts at the x-axis, where y equals 0, and it goes up towards the positive numbers. So I want to be greater than or equal to 0. And if I just look to the right of the answers, I only see that or equal to 0 in the bottom two. One of those is greater than or equal to 0. The other is less than. Well, we're above 0, so that's greater. So I'm going to pick that one and check my answer. And it's correct. So that's the type of problems we would expect in this homework. Here's another one. Again, it's part 1 through 4, so we'll have the same 4 parts in there, only now we'll be multiplying the squared terms by negative 1/3. The next homework, now it's a positive 1/3. Again, creating the table, part 1 of 4, so we'll have the same 4 parts there. And now we're graphing a different one. This one is a little closer to the first one I did, where I had x squared minus x plus 6 or whatever it was. Only now we've got to cube it. So let's go ahead and do this one. Y equals x cubed minus 5. Let me get another layer here. And let's see, we've got y equals x cubed minus 5. I didn't remember what x values they wanted. Oh, they just want me to graph it. Okay, so first let's get a few points here, just so we can graph this thing. I'm going to, again, create an XY table. They won't ask me to fill one out, but that's okay. I kind of like the values -2, -1, 1. Oh, let's put a 0 in there. 1 and 2. It's pretty easy to do those numbers. So I'm going to replace x with this thing that I'll cube and then subtract 5. I'll just go ahead and write that for each of these because I know I want to do that. And I'm just going to replace within these parentheses the x values that we have in the table. So this will be a -2, this will be -1, 0, 1, and 2. Now let's talk about that -2 cubed. So -2, now it's in parentheses, so we're cubing the negative as well. So we've got -2 times -2 times -2. That's what that cube means. We've got three of those multiplied together. Well, -2 times -2 is a +4. And we multiply that by -2. Now we have a positive times a negative, which is negative. 4 times 2 is 8. So -2 raised to the third power is -8. And -8 minus 5 is -13. Same sort of thing here. -1 times -1 is a +1. And that times the third -1 is -1. And then we'll subtract 5, and we get -6. Do the same thing with 0. 0 to any power is really 0. So then we've got that. Minus 5 is -5. Let's go ahead, and 1 to the third power is going to be a 1. Minus 5 will be a -4. And then we've got 2 to the third power, which will be 8. Minus 5 is going to be 3. So we have this set of points now. I can't go down to -13, so I'll skip that first one, but I can do -1, -6. It's down here. 0 was at -5. 1 was at -4. Well, this looks like a straight line. But when you get to 2 and realize you're up here at 3, and then think back to that -2 and we're down here at -13, you can see that the graph of this thing comes up, jogs a little bit over, and then keeps going. So that's kind of the graph of these cubics. They come up, over, and keep going. That's a common cubic shape. Now the domain, once again, will be all real numbers, because any x we plug in is going to work. The range, now you can see with the arrow on the bottom down here and the arrow on the top, it's going to keep going both directions. So once again, it would be all real numbers. So that's kind of what we expect to see here. Let's go into our problem and see if we can graph this thing. Now, when I click on the coordinate system and I need to pick a tool, I'm not going to pick the quadratic tool because it's raised to the third power, not to the second power. So I'm going to come over here to the 4-point cubic tool. That's the one I want. And we saw that at, oh, what were my points here? At -2 was -13. So I need to get that one. So -2, -13, that was right here. At -1, we got -6. At 0, we had -5. And at 1, we had -4. And you can see it finishes the graph for me. I can go ahead and check that answer, and we're good. And so we don't have a lot of problems here, only 7. You can see this one, problem 5, is also a cubic. Problem 6 is also a cubic. And problem 7 is a cubic, only now we have more terms. Again, describe the domain and range and so on. And so with a cubic, you will use 4 of the points that you find. They ask us to fill in the y values for 5 of them, but we will only use 4. So that's essentially what we're doing in 15.4 and 15.5, is we are graphing quadratics and cubics, essentially using XY tables. They gave us a bit more information in the book than I'm talking about here because, well, in the book, they wanted us to know a bit more, and the homework and the quizzes didn't seem to require it, so I didn't want to spend too much time doing it. Let me quick draw a quadratic here. And you can see, let's label some of these points so that you're aware of what they are. This point down here where it changes direction, we call that a vertex. and there are formulas for calculating that. Also notice that this looks kind of symmetric about some line here through the middle. That line is called an axis of symmetry. I know I really made it wide and dashed and stuff, but it really is only a single line. But that's the axis of symmetry. You're not asked about that on the homework. You are not, I think, expected to know that on the test. I haven't written the test yet, but if we are asked about that on the test, I'll go back and cover it in a bit more detail. But I thought you should know that. And well, sometimes the parabola is up here, so it doesn't have any real solutions. A solution would be where it crosses the x-axis. But we're not concentrating on that. It is in the textbook, so if you read the textbook, you'll see that sort of information. Just know that it's clearly not in the homework. If you have questions, reach out to me and we'll see if we can help you out a bit. But you've seen a couple of sample problems, give them a shot and see what you think. And I'll see you in class.